All right, our first question that has been sent in. And this is how I do questions. When the question's sent in to me, I send it over to my handy dandy Math 120 folder I just created, and we go over the question. Now, when I go over a question, and this is important for those people that like to ask questions 5 seconds after I tell you, okay? Because I don't repeat myself. Section 2.2, number 15. Well, what does that 15 mean? Well, if you look in the book on chapter 2.2 homework and look at number 15, this problem will be like it. It will be similar. It will not be the same. It will not have the exact same numbers, but it'll be about the same problem. If you look in your online homework on number 6, it will be like that problem. It will be similar to your problem on number 6 online homework. Okay, so what I tell students is I will say 2.2 number 15/6. 15 in the book, 6 online. 2.2 15/6. And I'll say 2.2 15/6 like 6 times. And as soon as I pull up the problem, what will somebody ask? What number? And I'll say I have no idea. So, you know, when I leave this on the board and I put it on the board for 5 or 10 minutes, you know, might want to write it down. Okay. So it says construct one table, relative frequency, and one table that is probably cumulative frequency. But let's see what it says. Construct one table that includes, okay, we've got to look at the dang old frequency distributions of dang old right there. So take a minute and copy the problem down. And of course, if you got your book, or if you've got the online homework printed out, you can pretty much, you know, you don't have to copy it. You can just do the numbers of your problem. Now this is not a single chart. It's what? 2 separate charts. Now, if you want to do this, and I'm going to do it in Excel spreadsheet, the reason I'm going to do it in Excel spreadsheet is because I don't want to draw a bunch of charts on the whiteboard. So I'm going to let the Excel spreadsheet have the charts for me. Give y'all a few more seconds to copy that down. Okay, so we're going to copy that over to the Excel spreadsheet just for organizational purposes. Well, thought I pulled it up. Okay. Just pulls up and doesn't show up. There we go. Finally. And I'm just going to put it right here. And there's the 2. I'm going to copy this one over a little bit. Control X. Control V. Okay, everybody with me? Yeah, Hubert. No, Hubert. Okay, class. Glad everybody's with me this morning. Alright, so if you want a cumulative frequency or a relative frequency is basically percentages. That's all it is. So go out to the side of it and put percentage. A cumulative frequency is a count. Alright, so relative frequency. First of all, you got to have n. What is n? Well, it's the summation of what? Your numbers, Hubert. That's right, class. Thank you. And there's your n. So what would the relative frequency of 2 be? 2 over what? 25. So 8% or 0.08. And you can write it as 0.08 or you can write it as 8%. But do be aware of what the instructions say. I'll look back at it in just a second. And I want to lock F4. And I'm going to pull it down, copy down. And there should be your relative frequencies. And if you wanted to turn it into percentages, just hit the percentage button and there's your percentages. And that's how you do a relative frequency. Relative frequency is a 25-cent word for what? Percent. I can't call it a percent because that'd be too simple. Alright, so let's do a cumulative frequency. Well, what's the first number in the cumulative frequency? This number right here. So 2. Alright, what's 2 plus 0? 2. What's 2 plus 14? 16. What's 16 plus 7? And 23 plus 2. And the last number of the cumulative frequency should equal what? N. Alright, you try the next one. Alright, so in this one you got 1. So what is, your first one is 1. You're going to take down each one, add them up to get your N. So just hit the summation key if you're using Excel and copy those down. And equals 1 divided by 25. And copy those down. And just so everybody will be happy, I want to put it in percents. And what's the first number? And what's 1 plus 2? And 3 plus 6? And 9 plus 16? And they should equal. So there is your information concerning the frequency distributions in this problem. Comprende? Now we go back to the problem and ask, okay, they say, okay, they just want us to do both. This is non-filtered, so we take it back to the Excel spreadsheet and we make this small and make this small and make this small and make this small, and just bear with me, man. I'm fixing it to where it won't go blank every time I turn around. There we go. So my relative frequency is 8, 0, okay, come on, 8, 0, 13 to 16 is what, 56? I make sure I can't see. I gotta look and see. Hold on. Trying to work this best I can. Okay, there's my percentages. I'm sorry. 30K of them all for 1. So what is 5 to 8? 0. There we go. 8. 13. See, dadgummit. What they're doing is trying to throw you off just like they're throwing me off right now. 8. 17 to 20 is 0. The next one is 56. And 28 and 8. And this one, 5 to 8 is 4. 9 to 12 is 8. 13 to 16 is 24. 17 to 20 is 64. And 0, 0, 0. Did I not put the right one? 17 to 20 is, yeah, 64. Alright, now we got the values in. Is that all it's going to ask? Oh, okay. I didn't know if it was going to ask you something. Okay. Do the cigarettes appear to be effective? It says construct an online table. Well, unfiltered or not filtered, that's the dang old Pall Malls and dang old Camels, dang old short cigarette, dang old rough. Dang old turn your teeth brown after the first one. I mean, so it's going like this. So it's skewed what? Skewed left. So all the data is on the what? Is on the right. So that means your older people smoke these rough ones. The Marlboro Lights, they're kind of what? They're kind of skewed right, which means a lot of your younger people, or I'm sorry, I thought it was ages. It's not ages, it's tar. Okay, I'm sorry. I wasn't even reading. I thought it was dang old 5 to 8 years old starting. Dang old behind the woodshed. Okay, it's not, it's tar. So does, it looks like the non-filtered, you're talking about 21 to 24 is 56%. So what does the filter do? Yep, so dang old teeth done get less yellow, I guess. There's three things in the world I never developed a taste for. One is beef liver, the other is smoking, and the other is coffee. I never developed a taste for those three things. Ugh. So yes, it seems like, yeah, turns your teeth less yellow or brown. So yes, looks like yes right there. And we feel good about ourselves. Alright, so that's how you do relative frequency and cumulative frequency. What does relative frequency mean? Percentage. What does cumulative frequency? A count, meaning you count and keep counting. That's all it is. It's nothing spectacular. It's nothing rocket science. They just try to make it out to be rocket science. Everybody feel good about that? Alright, so let's move back into our discussion about frequency distributions and all that good stuff. What we went over the other day. Well, I think we were starting to do the mean of a frequency distribution, correct? So let's continue on today with the frequency distribution, and let's move on with the standard deviation also. Anybody remember what section we were on? 3.2, thank you. Somewhere in there? Okay, thank you. Yeah, we just had, I think we did one problem with the mean of, I think we did that table, yeah, this table right here. I think we did it. So, the mean, we found the mean, and that's a good thing. But what about the standard deviation? Well, the standard deviation is going to give you a real nasty looking formula. And it's going to be very intimidating. And once I find it, I will show it to you. 96, thank you. No, that's not it. Well, it's not on page 96 then. No, this is the standard deviation of a, yeah, this is standard deviation of a regular list. See, they don't show it to you. That's another thing, this book. It don't show you how to find the standard deviation for a frequency distribution, but it asks you problems finding the standard deviation of frequency distribution. So what I'll do is I'll go to the homework and pull it up so you can see the actual problem, because that's where you're going to see it. So just give me a second and I'll pull up the homework problems. Doesn't even show it to you in the book. Now I have to take a minute to find it, because these are not frequency distributions. Probably in that's the mean. It'll ask for the mean and the standard deviation. I think it must be 3.3. No, it asks for the standard deviation. Just hold on, let me look for it. It'll ask. At least that's what I thought. And they don't give you, and the reason I need to pull up the homework problem is because they don't give you the formula, and I can write the formula down, but half of you will ask for it after I write it down, and after I erase it, so and that'll just irritate me, so we're not going to do that. There she is. And you won't find it in the book, so you might as well go ahead and write it down. Take a second and write that one down. I'll make it big enough because most of the people that can't see, where do they sit in class? In the back. So, and I'll blow it up one time, but don't ask me to blow it up anymore because if you can't see, you shouldn't be where? Sitting in the back. And everybody on the back row thinks I'm talking about them. I said all my classes, not just this one. We having piglets. Sorry. Okay. This formula is not as intimidating as you might think. First of all, put this right here in braces, right there. Okay. This is one part. This is another part, and this is the denominator. So the only mistake that people make is they think that you multiply n times this whole thing. You don't. The n is only multiplied by this thing right here. So that's why I tell students to add a brace here and a brace here. This number has to be bigger than this number. Why? Because you can't take the square root of a negative. And why would you get a negative if this number was what? Smaller than this number. So this number has to be bigger, and that's why the n is right there to make this number bigger than this number. All right? Now, the best way to do this problem is to start showing you how to do it by hand. And then there is a way you can do it on your calculator. Okay, but it's a pain because you have to type in the frequency distribution. Alright, so I think it's pretty simple to do it on an Excel spreadsheet, but I'm not telling you have to do that. But to show you by hand, I'm going to show you on the Excel spreadsheet. I'm going to show you by using the Excel spreadsheet, not to use the Excel spreadsheet. Alright, so I'm going to copy everything over. And this is the biggest thing that people are rusty on when it comes to Math 120, because not a lot of people get this in the what do you call it, high school classes. Some of you do, some of you don't. So So here's my frequency distribution. I'm going to put it over here because for a reason. Alright. Say again. Oh, I'm sorry. That's the problem. See, that's another reason people that can't see don't need to sit on the back row, because I forget to go up and down with this thing and it's a pain. So if you can't see, sit at the front or the middle or wherever you need to see. Wherever you need to see the best. Alright, so there's my frequency distribution. Now, why is a frequency distribution so tough? Because you can't use what? You can't use the classes. Because why? Well, 20 to 29. How are you going to calculate 20 to 29? You can't. So you got to find the what? You've got to find the midpoint. And that's going to be your x. X is equal to the midpoint. So in your notes, you don't have an Excel spreadsheet in your notes. You need to draw two columns, and then your third column you need to title X and put X in quotation marks and put midpoint, because you need to know that that's the midpoint of your interval. Now the way I do this is I go out here and I put the interval in separate numbers: 20, 30, 40, 50, 60, 70, 80. And then I go over here and I do 29, 39, 49, 59, 69, and 79, and 89. Now the reason I do this is so I can use the Excel spreadsheet to do the calculating. You don't have to do this. This is just for Excel. So now I can find my midpoint. What is my midpoint of my first one? Well, 20 plus what? 29, Hubert. Thank you, class. Divided by what? 2. And that's my midpoint for the first one. Now find the midpoints for each of the next ones. You can find it two different ways. You can calculate each one, or you can add the what? Class width to each one. So go ahead and do that. I want you to do it by hand, so hopefully you'll remember how to do it when you do it at home. I'm just going to copy it down. And I'm going to put these in the center, and I'm going to highlight this one in green. I'm going to highlight this one yellow. Is there a difference between yellow and yeller? Yep. Just like there's a difference between a whipping and a whooping. And there's a difference between naked and naked. Some of y'all have no idea what I'm talking about. It's your parents' fault. Alright. So, now, this is the problem that students have. They want the teacher to go and show them how to do every little step of the problem, when all they have to do is look at the what? Look at the formula. Alright, so everybody, take a look at your formula. What does that first one say? It says n. Well, what's n? You add up all your frequencies. Well, we'll do that later. We don't need n right now. N is the least of our worries. But what's that first one say? The summation of f times what? Do we have x squared? You need to take another column and do x squared. Because you have f. You don't have x squared. I'll do the first one for you. 1. 1 squared is 1. Alright? Now y'all do the other one. Yeah. I'm sorry. I thought I was doing frequency. I'm sorry. The first one is what? 20 what? So that's, you can do it on the calculator. I have no idea. I'm not Rain Man. 24.5 raised to the second power. Dang old 25 raised to the second power. Dang old, what, 625? So this one would be less than 625. Dang old, I see a bunch of TI-81, 84s on these daggone phones. Dang old Wabbit Ian. Dang old free TI-83. Dang old Apple people can't get it. Alright, so we got to get x squared because we don't have it. So we go to our handy dandy and we type in x squared. And that's the good thing about this Excel spreadsheet. It's real simple to do it. And let's go ahead and we'll color this blue. I had one piglet so far. Hopefully we'll get 6 or 7 more out of that one. Alright, so equals this raised to the second power. Dang old 600.25. Check your numbers. Go back to the handy dandy. I know y'all can't hardly see it because I've been going up and down. Sorry. There. Go back to your handy dandy formula. And we got x, we got f times x squared, n. Well, what is n? Well, that's pretty simple. We'll put n right down here. There's n. Now, I'm going to go over here and I'm going to put 2 other columns, and I'm going to go over, I'm going to skip a little area right over here, and I'm going to put one right here. And I'm going to call this one f times x squared. And I'm going to call this one f times what? Well, how'd you know to call them those? Because that's what I need in the formula. Go back to the formula. Hang on, where'd my formula go? Don't tell me I lost it. I guess I did. It's a conspiracy. We all know whose fault it is. Whose fault is it? There you go. Y'all are learning. When the going gets tough, blame it on Bush. Okay, I don't care about the problem. Here's my formula. F times x squared. Okay, we got that column. F times x, we got that column. And we got n. So we got everything we need now. We just got to do the f times x squared and the f times x. And we got everything we need. So let's go back to it. F times x squared. Let me put these in. I can't stand not to be centered. I'm sorry. That's one of my little pet peeves. And we'll color this one purple. I don't like that purple. That's too dark. Ooh, that's too dark. Let's go more colors. There we go. Something magenta. And we feel good about that one. And let's go ahead and color this one something that won't clash with magenta. Maybe gray. Alright, so f times x squared. So I'm going to go over here. Equals f is 1 times x squared. And hit enter. And y'all check your numbers. There's those numbers. And f times x and there's those numbers. So what we're going to do is we're going to add up, we're going to calculate n times 600, and then we're going to subtract 24.5 squared, and then we're going to put it over 93 times 92, and we're going to do that 5 or 6 times, and then we're going to add them all up. Right? No. That's the long way to do it. You'll get the same answer, but it's the long way to do it. Add up these two guys down here. Add them up. Dang old summation. Dang old sum. And what are these three things that I've got right here? What are they? That's not rhetorical, I'm asking y'all. They're the parts of your what? Of your formula. That's all you need. Alright, so what I'm going to do is I'm going to go down here and I'm going to put standard deviation is equal to, and I'm going to put the parts of the, so 93 will be equal to this guy. Oops, sorry. Times this guy. Now I'm not doing the math, I'm just putting it in dang old order. And then we're going to minus what? 6688.5, Hubert. Yes, that's right, class. And what are we going to do to 66.85? What are we going to do to it? We're going to square it. Good, y'all are following along. Dang, square. And all that is going to be over what? 93 times what? 92. So that'd be equals this guy minus 1. And that's what your formula should look like when you're doing it by hand. 93 times that BA number minus this number squared over 93 times 92. In other words, after you do these things up here, do you have to do any more tedious math? No. You go down here and let's do some organization again. SD is equal to, well, let's go ahead and do 93 times this number. There's that BA number. Minus this number raised to the what? And is that number going to be smaller or bigger than the first number? If you want things to come out right, it's supposed to be smaller than this number. Over 93 times 92. Top number is 40, the BA number minus this number. And it should come out to be positive. And that's over this number. And I need to go back and change something. This is not the standard deviation, it's the variance. You just need to change that. I always do that, I forget. Variance is something we don't use a lot of. We don't use it very much, and I just skip it and go straight to the standard deviation. Variance is equal to this number divided by this number. And there's your variance. Now sometimes your book or notebook or homework or test or whatever might ask for the variance. Well, there it is. I'm going to color it dang all orange. Now, the relationship between the variance and the standard deviation is always the same. Always. Can anybody tell me what the relationship is between the variance and the standard deviation? Not half, but the square root. And if you want to get the variance from the standard deviation, you raise the standard deviation to the what? Second power. Remember that relationship. That's true with standard deviation and variation all through the book, all through statistics. So if I want my standard deviation, I just dang old take the square root of what? The variance, Hubert. That's right, class. Raise it to the 0.5 power or 1/2 power. And there is your standard deviation. Now we're going to talk about standard deviation and what it is, because half the people that take probability and statistics can't even tell you what the standard deviation is, much less the mean. Some people can't even tell you what the mean is. I'll tell you what the mean is. You add them all up. No, that's not what I'm talking about. What is the definition of mean?
Average.
The average. Yeah, that's the average, but that's not. What is it? Somebody tell me what it means to have an average. Well, 99.9% of you cannot tell me because you don't know. In other words, if I was to show you a graph, a bar chart, what is the average? Well, I'm fixing to show you, and then I'm going to show you what the standard deviation is. Now, whether you are doing a list of data test scores or if you're doing a frequency distribution, okay, it doesn't matter. The mean and standard deviation, when you crunch all the numbers, the mean and standard deviation is the same thing. It may not be equal, but it's the same thing as far as the definition. What I'm going to do is I'm going to show you what the mean is. If I was to tell you to graph all your data, and you graphed it on a bar chart or whatever, you would get something every single one of my rooms. When you hit the pen button, it automatically go to calibrate, except for this one. I ask you to do a bar chart, and let's say you have data that goes here, and or histogram, whatever you want to call it. All right, there's your data. And I ask you what the mean is. And y'all spit it out. 72. What is 72? What is it? 70. Yeah. What is it? Tell me what the average does. And 99.9% of them can. So, not in here, understand people that are asked. All right. So let's say that I take off, let's take this red pen, and I take off this guy right here. And I cut him off and put him right here. And then I take off, well, I didn't draw it right, but anyway. Let's say we take off this guy right here, and we put Texas. And work with me here, I didn't draw it graphically correct, but we're going to take that off and we're going to put him right here. Work with me. In other words, stretch it out a little bit. And then we take off this guy. And I put dots. And we put him right here. What have I just done? I made the variation equal what? 0. Because now there is no what? And where there is no variance, that is called the what? So the mean is the number that represents no what? Variance. If you was to take off all these things that are above the mean and chop them off and stuff them in these little gaps right here, that would represent this blue line right here, which is the mean. That's the number that would happen if you could do this right here. Now you know what the mean is. The mean is the number that represents no variation. So is it important? Yes, it is the center, because that's the best measure of center, because it is actually this line right here that has no variation. Now, Now that you know what the mean is, what is the standard deviation? Well, the best way to show standard deviation, I get criticized for this. I get criticized for this by my students that I threw out last semester. Y'all read my, y'all read my professor. She got mad at me last semester. I threw her out of class because she was rude and belligerent. And she went on there and put all kind of bad stuff about me. Yeah, it bothered me. I'll tell you it bothered me. But one of the things she put on there was I talked about a bearing and a shaft. And this is the part I talked about. And if you're not intelligent enough to understand it, then you can go on right my professor and bash me. Alright? There's a bearing, and a bearing and a shaft. Here's the shaft. And on each end, there is a bearing. Now somebody tell me what the bearing is for. Anybody know? I'll have to stab at it. Alright, well I'll just take a minute and show you what a bearing is, because some of y'all have no idea what a bearing is. So we'll just take a minute and show you. No coughing in class. I don't know why y'all have to cough. I don't like y'all sick or anything. Right? Dang, y'all need some juice. Alright. Let's just go to bearing. Bearing and shaft. There we go. Y'all know what a bearing is now? Y'all see what it looks like? That's a bearing. That's what I'm trying to show you right there. But most of the time they're rounded, but sometimes they're not. The bearing is this piece right here, and what does the bearing have around it? It can be a ball bearing, which means what? Little steel balls around it. Or it can be a split roller bearing, which is instead of balls, it's got little rollers roll around. And there's a ball bearing right there. Now, there we go. There's the picture I want right there. Dang old view image. Now, what can you tell me about a bearing and a shaft? Anybody mechanical in here tell me? Some of you mechanical drawing people, anybody ever went into CAD or a mechanical drawing class? You draw all these pictures of bearings and stuff. What can you tell me about the relationship between a bearing and a shaft? Can a bearing fit, can a shaft fit in the bearing loosely, or does it have to fit tightly? Why? Why does it have to fit tightly? Huh? So the bearing will move. What happens if it's loose? And what happens if it turns at a high RPM? Huh? What'd you say? Why? It's going what? In other words, if this doesn't have a tight fit like this, the shaft is hooked up to a motor somewhere. Alright? And it's just going to turn and turn and turn inside this bearing, and the bearing's not going to move. And what's going to happen is the slot, and that's what it's called, a slot, in mechanical term. It's going to beat that bearing what? It's going to beat it to death. And eventually, what's going to happen to the rod and the bearing? It's just going to, and then you're going to stop the line of production and all that good stuff. Now, what the heck does this have to do with the standard deviation? Well, what do we want? What do we want with the shaft? We want the shaft to be a tight fit with the what? Bearing. Does everybody understand that? It didn't go over your head or anything, I hope. So what do you think in mathematics or in statistics? What do you think we want in terms of data? Wow, you got it. Such a concept. He said it the way exactly you should have said it. A tight what? A tight group. Precision, accuracy. There's difference. All right? You can be accurate and not be precise, and you can be precise and not be accurate. Think of it like this. Let's say that you're at boot camp, Paris Island, South Carolina, and you were going through second phase, and second phase is your dang old. Where is my whiteboard? There it is. That's your weapon. You learn how to fire your rifle. And let's say you have a target, and this is the way the targets are down there at Paris Island. And this is your bullseye right here. And let's say you shoot 5 rounds. That's 5 bullets for those people who don't know. 5 rounds. And they go down range, and you hit 1, 2, 3, 4, 5. Let's say that that's about the size of a pie pan. 8 inch. Are you accurate or are you precise? You're accurate. Why? You group them together. Is the group tight? Yes. Well, what's not tight, Hubert? Let's see. There's one, there's one, there's one. All right. These group, this is a sloppy group. The person, I'm trying to teach you, okay? This sloppy group, meaning the person is not breathing. Looks like they're not breathing right because they got one up high and one down low, so they're not breathing correctly. They have no idea how to hold their rifle. They're squeezing the trigger. They're pulling the trigger instead of squeezing it because you got one round over here way to the right of these two. So they squeeze the trigger here. They're breathing right here and here. This one, they pulled the trigger instead of squeeze, close it, or whatever. I don't know what the heck happened here. So this is a loose group. It's not precise. This one is precise. Is it, accurate. Is it precise? Why? They're supposed to hit the bullseye. So this tells me, are they breathing correctly? Yes. Are they squeezing the trigger? Yes. So what's wrong? The aim is off. So that means that, and they're putting it right here, so that means that the rifle's off, so they got to move it 2 clicks, probably 2 clicks to the right, and maybe you have to click down. But that's what, now, what does this have to do with it? Has absolutely nothing to do with what we're talking about. Yes, it does. Because if you look in your book, there is precise inaccuracy in there. If she'd have read her book, she would have seen that too. But anyway, this is a what group? This is a what? What do you think this is? Tight. There's that word again. So, what does that have to do with numbers? Well, in statistics, we want tight numbers. And how do you define tight numbers? Tight numbers, the lower standard deviation, the tighter the group. Lower the standard deviation, the tighter the data. Now, how do you know if the standard deviation is low? Well, it depends on what your numbers are. If your numbers are 10 through 20 and your standard deviation is 105, then either you've done something wrong or your data is just all over the place. Okay? If you have 10 to 20 data, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and your standard deviation is 1.2, then your data is very what? Tight. And you know your data is valid if it's tight. If it's not tight, it's sloppy. It's all over the place. Tight, accurate. loose, sloppy, you don't want it. Is that a concept that's hard to grasp? I don't think it is. So remember this. Standard deviation is what tells you if your data is tight or all over the place. So let's look at this. What do you do with the mean and standard deviation? Well, you remember this guy? Well, this is what I tell students to practice on. And you will do this until we get to chapter 6. So you might as well get used to doing it. What goes in the center? The mean. And then the standard deviation is measured 2 to the left and 2 to the what? Right. Now, a while ago, we did the standard deviation, but we didn't do the what? Mean. So we need to go back to find the mean. So let's go back to our Excel spreadsheet. And that's not hard to find because we already got the data. And I'm going to hurry up. I know some of y'all are going into cardiac arrest. What is the summation of f of x? 6688.5, right? Now what do we do with that? We just put it over what? 93, and that's our mean. So I'm going to go over here. I'm just going to go right here. And I'm just going to go mean is equals this guy divided by this guy. And there's our mean. Alright, so y'all remember that. 72. Somebody remember 72. And we're going to call the standard deviation 14 because I don't want to do decimals in my head. Alright, so 72 and 14. Now on homework and test, you need to do 72.91 blah 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 times plus, you need to do that in your calculator. But for instructional purposes, so I don't get all messed up. 72 and 14. Everybody with me? Alright, go back to our handy dandy whiteboard. 72 goes in the middle. Alright, take the calculators out. What's 72 plus 14? And what's 86 plus 14? Dang old 100. And then go the other way. Now if you're going to the left direction, do you add or subtract? Okay, so 72 minus 14. 58 minus 14. Huh? 44. Now I have 2 standard deviations to the right and 2 standard deviations to the left. Now, is this data pretty tight? Well, let's look. 72 is our mean. What is our standard deviation? 14. 14 versus 72. Is that tight or sloppy? Huh? No, wait a minute now. 72. What do you know about standard deviation? The higher it is, the sloppier it is. The lower it is, the tighter it is. So what's our numbers that we're comparing it to? 72. Or look at your numbers. Your numbers 72. 72 is the mean, so if we had a standard deviation of 60, then you know your numbers are what? Sloppy. But what is our standard deviation? 14. So what is our numbers? They're tight. Alright. Now, look up this in your book. I don't know how to spell it. I think it's empirical. I don't know. I think I want to put an H in there all the time. Empirical rule. Y'all have to look it up. It's in your book. Look it up and study it for the next class, which is Wednesday. Because we're going to talk about 2 standard deviations to the right and 2 standard deviations to the left, and how many percentage points is between 2 standard deviations. I need to call the roll before you leave. And y'all can leave after I call the roll.